Hello and welcome to the third and last in the series of webinars from Cimteq on the topic of increasing profitability within smart cable factories. Today's webinar is called How to Transition to a Smart Cable Factory That's Ready for the Future, Where to Start and Where You'll End Up. I'm Ken Jones and I'm your host for today. I'm the Digital Marketing Manager for Cimteq, and today's webinar is presented by Frederik Becker, Cimteq's Regional Sales Manager for Europe, the Middle East and Africa. And just before I hand you over to Fred, there is a chat box which you should see on your screens. If you have a question about any of the topics covered in Fred's webinar, please do use the chat box to set a question. Fred will answer those questions during the Q&A section. We want the webinar to be as interactive as possible and answer any questions you have. If your question requires a detailed answer, we are more than happy to take the conversation offline and continue after the webinar. So without further ado, I will now hand you over to Frederik Becker from Cimteq, where he will be talking about how to transition to a smart cable factory. Thank you, Fred.
Thank you, Ken, for the introduction. Good morning, everyone. It's very nice to see you here in the webinar. I'm already seeing some familiar names. Good to meet you guys again. So today, it's about something that we've talked about before. We've had a webinar like this before, but we decided to do it again. It's about the topic of how to go to make those steps that are needed towards the smart cable factory. A lot of questions have come up in the past few months on this topic, so we decided to touch this presentation up a little bit and do it again. If you have any questions, ask them straight away. Ken, please interrupt me in my presentation if any questions come in. I think interactive presentations are way better than just waiting till the Q&A. We're not so big as a group, so that's possible. So let's get started. Ken introduced me. I'm the sales manager at Cimteq. I've been working with Cimteq for quite a while, or a few years now. Feel free to connect on LinkedIn, reach out to me via email or website. Yeah. So very briefly about us, Cimteq is a software house. Some of you know us already. We've been around since 1998, and we have a pure wire and cable focus. We only do software for wire and cable industry. Our main products are Cable Builder and Cable MES, plus the services around it, and about 250 factories use us worldwide at the moment. Now, the agenda for today is, or the points we're going to discuss is, why do we need a smart cable factory? Why is it relevant? Isn't it just a buzzword? We're going to cover the next buzzword, digital twin, and then we're going to look at the data flow in the smart cable factory. And really the question of answering the question of where should I start? What is the first step to where do I invest first? Because a lot of people have this question because there's so many options around there in the market. And then with our Q&A session. I'll try to be quick. That's why I said interrupt me if you want to. That's all fine. I've got the chat box open now, so I can see what you're talking about. Okay, so a little session that I want to add today is really related to the current situation. I know from some of our customers that during this pandemic situation, the COVID-19 situation, they are faced with more challenges than they were faced before. It has become more difficult to grow profits in this current changing market environment. I know some of you guys are not impacted negatively by COVID-19 at all, but some of you are. And this actually relates to the smart cable factory topic very well, because now in such an environment, or what people did before, if they wanted to grow their profit, they just did more of the same things. They bought new machines to produce more cables. They added new products to their portfolio to sell more. But in a environment maybe where demand is shrinking, you cannot do these things anymore to grow profits. So what we're talking about now is how can we improve our profitability without adding new things? How can we make ourselves more efficient? How can we accurately understand which products contribute the most profit to the company and which don't, so that you can focus on the products that deliver profit. Or if you say, okay, we need to react, we need to go into new markets now that are less impacted, you do want to be able to understand the impact of this new market, of the new designs, of the new cables before you make them. In an early planning stage, you want to see the impact. You want to see how it impacts your manufacturing, how it impacts your profitability. And of course, in such a time, if you need to change, if you need to adapt, it's critical to shorten the time from having a new product idea or a new product inquiry to the delivered cable. That product cycle needs to be as short as possible, because you want to have, like in finance, you talk about the cash-to-cash cycle, and that's basically it. So this is how the current COVID-19 situation ties in with the idea of the smart factory. These are the things where we will be working on in the smart factory to make the companies more robust, more sustainable, even in a rough environment. And the other thing I forgot is, of course, there's fluctuation in companies. Experienced people leave, young people start, and if all the knowledge of cable making is just in the head of very few people, that's a business risk. So you want to bring the knowledge into the process. The process should have that knowledge about cable making, cable designing inherently, so that you can the company owns the knowledge and not only a few individuals. So what is our definition of a smart factory? There's a million definitions in the world, but we've got a few things that we decided, okay, this is the most relevant to us. For us, a smart factory, especially a smart cable factory, is a place where manufacturing and business processes are digitalized and automated. Okay, so far not very new, not very surprising, and we've been there already. Some of you are there already, but there's more to it. It's also a place where these processes are connected, so we're stepping away from those information silos. We're exchanging data between the places, and this is where there's more difference between the factories. Some have driven this connection further than others, but now is really the time we can leverage the benefits of these connections. And the other key element is decision making. In a smart factory, you want to be able to only make decisions on the most important points, and some other points, the decision making should be automated to a high degree. And whenever you need the human decision making, and we don't want to get rid of human decision making, but whenever you need it, it's supported by accessible and high quality live data, so that you know what you're deciding on, what the impact of your decision will be. And I think that's a key element of the smart factory, that information that you get to make your decisions. Now, we talked about it during this COVID slide, but why do we need a smart factory? In simple terms, it's about two things. It's about efficiency, and it's about speed. So you want to use less resources to do more, and that means you want to reduce scrap, you want to reduce human error, make the right decisions. So it's inefficient to make the wrong decision, two wrong decisions until you finally make the right decisions. It's things like minimizing inventory, etc. And you want to do that quickly. Minimize your, as I said, your cash-to-cash cycle, react quickly to new market situations, and make your decisions quickly based on your live data, on the current situation, not on data from last year. So far, any questions? Nope. Okay, let's continue. So a common buzzword we see in the industry is the digital twin. If you ask about twins, which twin are we talking about? There's so many twins, not only two. So the way we see it and what we see most relevant and most critical for the cable factory, we see three twins, or three areas that need twinning, which is the product area, the business process area, and your production space, your manufacturing space. So a twin is basically a model of your real life, either products or processes or equipment, so that you can analyze that data, you can work with that data digitally to really understand what's happening and to make the process more efficiently. Let me give you an example of what I mean by this. If we talk about the product twin, a product twin is basically a database that contains the dimensions of your cable, like your diameter, your wall thickness, etc. That would be very simple, and I wouldn't classify that as a twin yet because it's not a full picture of the product. So the model goes on. You add layers to it. For a cable to accurately describe a cable, you also need the materials it's made from, plus the quantities that are needed to make it. And now you see the model is growing, and you can suddenly do more things with it. Like you can build your bill of materials based on this data already. So here's the digital twin that allows you to build the material. You change bill of materials. You change the material, the bill of material changes. So that's the idea behind the digital twin. Oops. You want to have the routing information, the design header within the item master data as an inherent part of the product design or the product itself, which makes it possible to feed your ERP with relevant information. You can also add a layer of the cost that it takes to make the product. So you have your cost simulation, and you can build those twins without any limit. At some point, you need to cut off. The other layer that I added here in this example is the performance simulation. So you can, for example, add physical performance simulation or electrical performance simulation into your digital twin. And that's really a decision of where you want to have it. Maybe you don't need it in one twin. Maybe you just draw from your dimensions and materials and do that simulation ad hoc when you need it and it's not part of your twin. But like roughly, this is something we cover in our product cable builder. I think that quite a few of you have already in use, or you're implementing it right now. Yeah. So this was just one example, but how does that all fit together? How do I make these digital twins? How do I convert that into a smart factory? As I mentioned before, this is about connecting the data. And we really want to talk about connecting these three spaces. So I've got this slide that some of you may have seen already. We've got the three spaces: the product space, the business space, and the factory model, factory space, twin, whatever you want to call it. And you've got these different things residing in the spaces. So you've got your design solution, you've got your ERP in the business, covering the business processes. Of course, this is a simplification. There's a lot more going on in the business than just the ERP. But for us, for our explanation, that simple pink bubble is enough. And in the factory, it's also quite complicated. But if we want to simplify things, make it understandable, basically we're talking about the machines that provide analog data or raw data to the PLCs. The PLCs then can interact with a SCADA type platform or IoT. Next buzzword, so we've got buzzword alarm today. Your IoT platform that collects the data. So these IoT SCADA platforms, they have the skill to connect to different types of PLCs or interfaces in the factory and collect that data, store the data, make the data accessible for different purposes. Now, if we want to look at the data flow, I mentioned it before, from the design team, you would get things like item master, the BOM, and the routing, and you would integrate that with your ERP system so that your ERP is always up to date with the latest design information from your design team. The ERP issues production orders to the factory, issues material, etc., etc. Now, when you want to make a cable, the BOM on the production order isn't always enough. You also need product information, manufacturing instructions, quality parameters, your tolerances, your recipes available on the shop floor, and that can come from the design team, from Cable Builder as well. Sometimes that route doesn't go this way directly into the shop floor, but sometimes it goes via the ERP. That's fine. There's many ways of doing it. That's not the point here. Then, of course, your shop floor has to report back to the ERP. How many meters of good cable did I make? How much work in progress do I have? How much scrap did I have? How many non-conforming meters of cable do I have? I know, like when you make cables, there's always everything in 100% conformance, but some customers are known to have sometimes non-conformances. And sometimes customers don't use all the materials. So the shop floor doesn't use all the materials that has been released previously. And that needs to be returned. Lots of manual reporting or semi-manual reporting that needs to be done to make the ERP happy. Of course, the design team wants to have a share of information from the shop floor as well. They want to know how well did our products perform in production. Are our tolerances tight enough? Can we shave off 1 millimeter or 0.5 millimeter to save materials? Or were the tolerances too tight? Are we making a lot of non-conforming products? This kind of information. Often this gets lost in everyday business, but it would be really useful to have that in the design team. And of course, the operators are busy interacting with the systems, with the machines, with the equipment, entering recipes into the machines and loading machines, cleaning machines, you know the thing. And in this slide, I've got this little gap here that's intentional because there is something that lives in that gap, which would be, now, okay, it's cable MES, but in general, your MES solution, which really connects these three spaces. So if the ERP issues a production order, the MES executes it by breaking out the jobs across to the different machines or work centers that you have, telling the operators what recipes to use, giving them the instructions. It can be integrated in such a way that based on the production order, the MES will load all the quality parameters from Cable Builder, from the latest design version, and send the tolerances straight into your diameter gauges, lump neck gauges, and program the nominal and the tolerance values in those systems. And then the operator starts manufacturing, executing his job, and the MES system starts collecting data of how many meters of good product were produced, how many scrap did I have, non-conformance, return of material, provide SPC feedback to cable builder. So really what you see here, you've got so you've got the system, this IoT solution, the SCADA solution that many companies already have, and that SCADA solution is collecting data from the machines, from the sensors, whatever you have, collecting data, and it's super powerful. It can store huge amounts of data, and it stores it in a tool called Historian, which is a huge database. So you can store diameter values by the second, or temperature or pressure values by the second or millisecond. There's no limit to it. The limitation of these tools is that data maybe relates to a machine, but it doesn't relate to a production order or to a product design. So when you look at this, if you just look at the raw Historian data, for example, you will see how fast a machine was running, but you don't know how fast it should have been running for that specific product, for that specific diameter, etc. So you need to have that connection between what your nominal values are, which comes from your design team, with the actual values. And that's really the job of the cable MES, and that makes the MES so powerful, because it knows what the nominal values are, and then it can compare it based on these powerful SCADA solutions, IoT solutions, compare it with the actuals. That gives you a very good closed loop also in this regards, in terms of continuously improving your products, improving your efficiency. When we talk about MES, we don't only talk about a manufacturing solution, we talk about a solution that helps you in your business. You can also track things, make products traceable, again, of powerful things that you can then build on. The smart cable factory is not a definite state, but it's a continuous improvement process, if you want so. Another very common topic is advanced planning and scheduling. Typically, these solutions reside on the ERP level, telling the ERP how to sequence the production order, and so that communication is going on there. But of course, these systems, they benefit tremendously by having good quality data about the situation on the shop floor. But also, an arrow that's missing here is understanding the product designs and how a product runs through the factory. What is the work plan? What is the routing for a product? Customer was telling me they invested in a planning solution because planning was important to them, but they didn't have any design solution. And what happened was that the planning solution was telling them to insulate a wire on a cabling line, because the planning solution needs good information. And if you don't have good information, it's useless. So these systems become super powerful if you connect them, and if they're not fed manually anymore. And other things that are very common are utilizing the power of this Historian and system platform data, or IoT data, for your smart maintenance. So you can compare historic values with actual values to see if anything is not as it should be. And of course, that can integrate your maintenance schedules, can integrate with your planning schedules. So there's a lot of interesting things you can do here. And at some point, when you're building that model, at the beginning, it's interesting to look at each piece of data, but at some point you're not interested in the values anymore that just describe a status that is in order and doesn't cause any problems. So people now start to look also at AI, artificial intelligence based or machine learning based trend analytics, so that the system is telling you, hey, hang on, something unusual is happening. Please look at it, because it's not normal, but not comparable with the historic data that we have. Just as an additional layer of support for this. Questions so far? Nope. Okay. So where should we start if we want to build a smart factory? Now, I understand building a smart factory is not a 2-week job and not a 2-month job. It's a process that takes years and maybe it never finishes. There's always something that can be improved and where the data flow can be optimized. But one basic concept for building this digitalization and building these tools is you have to start capturing your data where it's being created. Capture your primary raw data and then enrich it and convert it into something useful. So classic example is the product data. It makes a lot of sense to collect the product information in your design team, in your R&D team, where people come up with creative new products. That's where they're creating data primarily. Another place where data is being created is, of course, in the business. You generate customer orders. You have your business processes that create a lot of data. So that's covered by the ERP. And if you start with the product data, you've got means that your product information, your master data is accurate, top-notch, and accessible. We don't need to talk about installing an ERP. Most customers have ERPs. I haven't seen one that doesn't have an ERP yet. But a lot of people think about ERP updates. They've got older systems, and for many of them, it's time now to invest into something new. And if that's your situation, it's super valuable if you have quality product data before you do your ERP. You don't want to validate all your old designs, all your old master data once again manually, just so that afterwards you buy a solution that builds you an accurate product model. Because the ERP will never be able to capture the complexity of a cable design. It may be okay for other products, but so far we don't know any ERP that can handle the complexity of wire and cable accurately. So keep the cable-specific solution data in cable-specific solutions and ERPs. Keep them as standard as possible. That will save you a ton of money. And in parallel, okay, the other topic that can be started and that many of you have started already is making sure that all your new machinery, all your new equipment, all your new sensors, gauges, they do have modern I/O, that they have modern I/O, that you're slowly building your SCADA, IoT type reporting system so that you have access to the data and that you can make use of it. That you get away from all these different controllers, your Eco Control and your uses and your Data Pro and whatnot, which have their own stored Excel list, and then you need to collate all these Excel lists to understand what's going on in the factory. But I know a lot of you are going this way already. So that's a good and ongoing process. We know this doesn't happen overnight in wiring cable. But it's a process that needs to be started and kept in mind when you do new investments. With good product data, access to machine data, and you're happy with your ERP, then it's also a perfect time to look at your manufacturing execution. How can I connect my ERP and machines and product data. And then I think the best thing is that you make the planning the last step, because the more accurate the data is that you can feed into your planning solution, the more accurate your plans will be. Because the reality is a lot of people have a planning solution, they do a rough plan with a planning solution, and then you manually tweak that plan to match it with reality. So if you want to have executable plans that you don't need to tweak manually anymore, that are truly optimized and not just roughly, then you do benefit from good and live data. So what I'm trying to say is, please don't start in the middle. We've seen it before. A customer came to me and said, oh, we need a smart quotation tool. Can you please come to us and sell all the quotation bit of Cable Builder to us? Now, I understand where they come from, because they complain that quotations take too long to create, and it's the salesperson reaching out to me. They cannot really interfere with the design team. But actually, it doesn't make much sense, because to get, for example, a quotation for a cable, you can build it on your data model that you already have. You've got your physical dimensions that define the material amounts. You've got the material cost in the system. You've got the manufacturing cost. So all you need to do when you have a proper data model is add a bit of margin to it and put that in a report template, which is your quote. And then you're good to order, or to receive the order. And that quote can then be converted into an order, as you do normally. I mentioned this also before, implementing your APS without modeling your production and products first. And if you've got plans that tell you to strand a conductor on an insulation line because it has free capacity, the planning solution is not useful. And it's not really the planning solution's fault. It needs the data. You need to know what the factory simulation looks like. You need to know what the product simulation or the product looks like before you can model it. Yeah, and I mean, with investing in the software, there's always some common challenges that we in Wire and Cable have. We've got this batch continuous production process, which is sometimes difficult to understand for outsiders. Not everyone in software understands, in those manufacturing solutions, understands the concept of lengths and drums. They may be very good in the food industry, they may be very good in automotive, but still getting the head around our processes where products can take very complex routings through the factory in a length and drum fashion is challenging. So you've got these system integrators, or you've got these software vendors that are very optimistic about finding a solution, then realize, hang on, there's more to it. It's not that easy. And it's the same thing when you do your in-house or custom developments. We've seen a lot of in-house MES or cable design solutions that never gave the customer the flexibility as an off-the-shelf solution, but at the same time was 3 times, 4 times more expensive. Yeah. So, like, you're moving on that path to the smart factory, and as I mentioned before, it's like the benefits are really to in the end, it's about money. You want to be able to do things quickly. You quickly want to understand the cost of something, of the product before you make it, or the impact of a new machine in the shop floor before you buy it. You want to instantly see the potentials for efficiency gains. If you see backlog piling up in your MES, constantly on one machine, that's where you need to invest, because that's your bottleneck. That's keeping you from producing more quickly. If you've got more scrap on a certain line or on a certain product design that causes more scrap, that's something you want to see. And your plans get better if you have good quality data. If you've got good plans, you utilize your factory better. Your OEE becomes better. You can do really good preventive maintenance and smart maintenance without doing too much. And you can move into these fields of trend analysis. You can automate a lot of these decision makings through AI, machine learning, etc. To also reduce the monitoring load. You don't need to run through the factory every day to see what's going on. It's still useful to go into the factory. I'm not saying that this shouldn't happen anymore, but you can focus on other things. You can focus on the people, how they are. You don't need to focus on machine performance. And yeah, you want to have optimal utilization of your people. You want them to do the things they're good at, and not to do repetitive data entry tasks, sharing Excel spreadsheets, copy data from one system to the other, and so on. And I mentioned it before, what-if modeling is a very powerful tool. If you have your data model accurately set up, you can simulate the impact of using a machine more, a machine less, employing more operators, and so on. And one thing I didn't go into detail yet, you can set this up, or this whole smart factory, in basically two different concepts. For like some of you make a lot of the same product in large quantities. That's fine. There you're very much looking at the efficiency part of it. But you can also set things up in a very flexible way. That's when you then look at the speed part of the smart factory. Sometimes it's more important to get a unique product out the door, and not so much about doing it the cheapest way. But then it's very important that you do it as quickly as possible, because the more you can do of that, the more you can earn. And that's something that the smart factory should enable you by helping your decisions, by providing the data to the right people at the right time. So very briefly, the quality of your data models drives your efficiency and competitiveness. ERPs are commonplace. The next step is your cable design process that you should look at, and the cable design database. So if you want to get started, start with your cable design, because you will use it throughout all the other parts of your business. The better your product data, the better the other systems will be. And whenever you see an Excel spreadsheet, that's a personal pet peeve of mine, it's an opportunity for improvement. Excel is abused everywhere for things it hasn't been designed to. Excel is not a database, and it's now so easy to have good database type tools that you really don't need Excel anymore, at least for ad hoc solutions. Unless for ad hoc solutions, but if you use an Excel continuously over months and just add data to it, then it's the wrong tool. So that's it from me. And here we are at the Q&A session. I hope you like what you heard.
Okay, thank you, Frederik, for that presentation. I'd like to open up the webinar for questions. So if anybody has a question, please use the chat box, which you should see on your screens, and just press enter, and we'll see the question pop up, and Fred will answer that for you. Fred's here for another 10 minutes or so, so now's your chance to put a question to Fred on anything he's covered so far. There's a lot of detail there. Thank you very much for that, Fred. I've got a couple of questions just to start us off. Fred, can you provide us with any real-life examples of the benefits that have been given to a factory by ensuring the design and manufacturing data is connected together?
One example, I won't mention the customer, but they were quite happy. They invested in Cable Builder and Cable MES. And sometimes in the manufacturing reality, people grab the wrong type of material and load the machine with the wrong type of material. So they had this new system set up. The Cable Builder was sending the recipe, the BOM, and the instructions to MES, and MES required the operator to scan the materials before they load machines. And through that process alone, many operators realized they've been scanning wrong materials, using wrong materials to produce the cable. I think it was a different variant of the same type of compound that they would have wrongly used, but that had significantly lower performance characteristics. So that was one example where it really saved them for producing scrap and was about the sheath. So that would have been a lot of money just in that one instance. And they said these things happen regularly, not often, but often enough to make a big cost impact. And that alone paid back the investment into these tools.
Oh, excellent. And what are the dangers of not implementing and not making that smart transition to a smart factory? What problems can a factory expect to run into?
I think the biggest risk is that you're being overtaken by the competition, and that you are not quick enough to react to changes in the market. The market is under pressure. I know you have a lot of capacity in the market, so you need to be creative with what products you sell. So it is quite important that you can come up with new product designs quickly, that you issue your quotes very quickly to your customers, that it doesn't take weeks until the customer has a proposal in his hands. And when you manufacture, you've got a lot of competition from all over the world. When you manufacture, you have to make sure it's competitive, and that you understand how competitive you are in your manufacturing. Not everyone understands how profitable their cables are that they ship out of the door. Only after they've shipped it out of the door, they see, oh, maybe we shouldn't have done this deal, or we could have asked for more, or we could have gone lower and maybe won the deal that we didn't win. So these are like the typical scenarios where the money comes back to you.
That's really interesting. So what are the financial benefits that a smart factory can provide to a cable manufacturer?
It really depends. For some factories, it's purely about finding those last few screws where they can tweak their efficiency, taking a little bit scrap out of my manufacturing process. And if you produce in volume, this can have a very positive impact by just reducing your scrap by 1% or overconsumption by 1%. But for many, just the simple fact that they understand the cost impact of a product before they make it, and that they understand the cost or the profit contribution for each product, is already super valuable. If you can make the right strategic decisions based on this information, it sets your path to growth again, because you know what to go after, and that you don't pursue, or that you don't ride a dead horse.
Okay, last question from me. Can you go into more detail about the what-if modeling that you mentioned within the presentation and how that works?
What-if modeling is really referring, once you build your data model, you can employ simulation tools. So, you can already do it in Cable Builder. You can, for example, model the cost difference of a cable when it's produced at nominal diameters versus at max tolerance. So you do a bit of tolerance stacking to see what the cost impact is if the operators all add a little bit of extra material, because your cores become bigger and the strand of the cores becomes bigger, and then you need a bigger sheath, and you add a little bit of tolerance on the sheath as well, and your bedding and your armoring. So all this costs a lot of money, and if you optimize these things, that helps. Another thing is if you understand what it takes to make a product, and if you understand the capabilities in your factory, it becomes simpler to use simulation modules like Simio, or forgot the name of the other one, to assess in your factory what the impact is of replacing an old machine, for example, with a faster one, or should I add a new faster machine to the old machine, keep the old machine running? What will be my most cost efficient way of achieving my targets, for example. So we're just scratching the surface here, but the importance is your modeling becomes better the better your data is.
That makes sense. All right, thanks, Fred. Okay, I'm going to leave the chat box open for another minute or so for any questions to come in. Like I said, Fred's here for another 5-10 minutes, so now's your chance to put a question to him.